I'm going to use Yenka, which is circuit prototyping software, to create a basic nightlight circuit and demonstrate how changing lighting conditions can be reacted to using a potential divider circuit. Okay, so we're going to bring in our basic components, and I'm going to choose symbolic, and I'm going to bring in my power supply first of all, a 9-volt battery. Then I'm going to choose a light emitting diode as my output device, and I'm going to choose a resistor which can be used in its simple form to protect the LED from too much power. I'm going to choose a single pole, single throw switch, because the basic element of control in a circuit is the ability to turn it on and turn it off. Okay, so let's just connect those up and demonstrate that we've got a functioning circuit. We complete the circuit, close the switch, and a light comes on. I'm going to change the value of that resistor there to 470 ohms, which protects the LED, but whilst still allows enough current to pass for it to give a nice bright light. Okay, so that's a basic circuit. However, it doesn't in any way react to light or dark conditions. I'm going to add my sensor area to that. So I'm going to bring in another resistor, because for a potential divider, which is a sensor system, you need to have 2 resistors. The second resistor is going to be a variable resistor, and I'm going to choose a sensor called a light dependent resistor, LDR. I'm going to choose one with a lamp here to show it. Okay, so there's our 2 components. Okay, if I just join those into my circuit, that was proving tricky. We're on there. Okay, so let's switch that circuit on. And currently, we haven't really got a great deal happening because our LED is not connected to the rest of the circuit. I'm going to just put a voltmeter into position here for a second, just to show you what happens at the point between these 2 resistors. And I'm going to change that to the value that we need, which is 33, and then instead of 33 ohms, that actually needs to be kilo ohms, 1000 ohms. Okay, so at the moment we've got the LDR showing, I'll close the switch, sorry, got the LDR showing a large 8.71 volts. Remember, we've got a 9-volt potential supply, so we've got 8.71 volts making it through the resistor up to there. As I reduce the amount of light falling onto the LDR, you also get a reduced amount of power coming this way. If I increase it, we get the power coming that way. So very high resistance at this point is giving us a high amount of voltage. Very low resistance, i.e. when it's light, gives us a much lower resistance. Okay, that's these two resistors working as a potential divider, which we'll explain in another video where we do some calculations. I'm going to delete this bit of wire here and delete my voltmeter for a second. And then I'm going to bring in the all-important component which acts as an electronic switch, which is known as the transistor. And that within my analog processing is a discrete semiconductor, and it's a transistor. Now transistors are used in huge quantities in all sorts of electronic circuits, so although it's got quite a complicated name, it actually is a very common component, an NPN transistor. Okay, now what happens with a transistor, just bring another one in to illustrate the point, you have 3 legs, the base, the collector and the emitter. Okay, when a little bit of power arrives at the base leg, it allows a larger amount of power to flow through from the collector and out through the emitter back into the circuit. So if you look at that configuration now in this circuit, we've got the base leg here, the collector there ready to draw power, and then the emitter passes it on. Now currently no power is flowing through here, and the reason for that is that the transistor has got nothing coming to the base leg. So if I connect it up now to the same point between the 2 resistors, can I do it? It's going to let me. There we go. Okay, we still don't have any power coming through the transistor. As I increase, if you remember the way it worked before, as I increase the amount of resistance at this point, more power goes in that direction, whereas previously it was able to pass through as part of the circuit. Now, instead of coming through here, more and more power is going to come to the base leg of the transistor. Eventually we reach the point where enough power is getting to the base leg. So at that point we've got 1.6 volts at the moment. If I bring that up just a tiny bit more, you'll see our LED turns on. So at 2.6 volts, it's actually less than that for the transistor we're using, about 0.6 of a volt. Okay, so we've got power flowing through the switch down to the potential divider. When the resistance is high, more power flows to the base leg of the transistor. When the transistor is switched on, it allows current to flow from the collector to the emitter and therefore turns the LED on. Okay, I'm going to put one more component in here, which is going to be another resistor, because that needs to protect the transistor, etc., from too much power. So I'm going to turn that around, and this is another limiting resistor. We'll give that one a value of 330 ohms and connect it up. Okay, so power is still able to flow through, but it reduces it to a safe level. Okay, so there we go. In light conditions, low resistance, the current flows in this direction. As the resistance increases, more current is forced to take an alternative route, therefore switching on at the base leg to allow power to go from the collector through to the emitter. Thank you, transistor. Thank you, potential divider.